Dear students, today we are discussing about one another problem that is very interesting. Uh, this will deal with the randomized test. In the in the previous problem, we have discussed non-randomized test. In this problem, we are discussing randomized test. Okay, what is the specialty of randomized test? You can see this. Let x1 x2 x4 x5 be a sample from binomial 1 comma p, where p is unknown and 0 less than or equal to p less than or equal to 1. Consider the simple hypothesis h naught xi follows binomial 1 comma 1 by 2. That is under null hypothesis h naught p equal to 1 by 2. And alternative hypothesis h1 xi follows binomial 1 comma p not equal to 1 by 2. So we have two hypotheses, null hypothesis and alternative hypothesis. Null hypothesis h naught p equal to 1 by 2 and alternative hypothesis p not equal to 1 by 2. Okay. Okay. P equal to 1 by 2 against P not equal to 1 by 2. So that means unbiased or not unbiased. A reasonable procedure would be to compute the average number of ones, because in a Bernoulli trial we have zeros and ones. So we can compute the number of ones. Suppose I should show you. Let it be x1, x2, x3, x4, x5. So suppose we obtain 1, 1, 1, 1, 1. So what will be the average? This is average. What is average? The average would be 5. No, let us consider this as a sum. So we have three situations. All the observations are 1, then the average is 1, and in this situation 100 the average is 0.2, and in this situation the average is 0.4. Okay, let us consider all other observations. I will take some data from. Okay, I will. Yeah, this is the. So I will paste this observation here. Let us take the sum as a formula. Fine. Let us compute for all observation. Okay, let us compute the average. What is the average values? Okay, so we can see that the average values of each and every possible observations. So these are possible observations. This is a possibility. Every observation can be one. This is another possibility. Uh, one of the observations is 0 and all other observations are 1. So in that case, the average is 0.8. So when we can say that the observations are unbiased, or when we can say that this when we can accept h naught p equal to 1 by 2, hmm? when we can accept this hypothesis. Okay, if this if probability is 1 by 2, then there is a equal chance for head and tail. Okay, or success and failure. So since there are 5 number of random variables, so we cannot exactly say some what is that, we cannot say exactly p is equal to 1 by 2 wholes, but at the same time we can say that if the if 2 of the observations are head and remaining 3 observations are tail, or if we consider 1 for tail and 0 for 1 for success and 0 for failure, if we observe 3 number of success or 2 number of success, 3 or 2, 3 number of success or 2 number of success, if there are okay, if the observations are like this, that means if the success number is 3 or success number is 2, then we can success number is 3 or one more, success number 3 or success number is 2. I will take the so two possibilities. So in this, so we are not getting exactly 0.5 value here, 0.5 value here, but at the same time we have to accept or reject p is equal to 1 by 2. So what we can do, so let us take either 0.6 or 0.5, then we can accept the null hypothesis p is equal to 1 by 2. Okay, that means a reasonable procedure would be, what would be the reasonable procedure? Yeah, that is, if this average minus modulus average minus 0.5 is, what is that, less than some small quantity, that means the difference between 0.6 and 0.5, that is less than c. So let us compute that. minus. Okay. So these values, look at these values, zero point 0.1 or minus zero point 0.1. Let us take the mode also. Let me look whether this is valid. Modulus return divided by, not mod. So there is no formula here. So let us take the difference. What do we, just to think about that. I will. So this is the mode values. Okay. This is the mode values. So this point 1, point 1, etc. Point 1. So look at this region. Look at this region. So in this case, if the observations are uh, this is actually less than some 0.11. Okay, if we take c equal to, if we take c equal to 0.11, so this is much less than so if we are observing this type of if we are getting these values for the difference, for this difference, yeah, this is difference, x bar minus 1 which is less than c, uh, then we would like to so we can accept the null hypothesis. So that is the criteria. Okay, what is the criteria? We will accept the null hypothesis only when we get x bar minus mu sorry, x bar minus p is less than 0.11. So that is the criteria we are using. So we have to find out c based on the what is that, probabilities of null hypothesis and alternative hypothesis. So we would like to choose c such that size of, so what are our conditions? The type 1 error should be less than or equal to alpha, and the power should be maximum, as far as possible maximum. So that is our criteria we have discussed in the last class. So let us take alpha is equal to 0.01. So the maximum error probability, type 2 type 1 error probability equal to maximum value equal to alpha value equal to 0.10. Okay, so using that equation we have to find out the value of c. See, since this is a rejection region, Since this is a rejection region, so what is the rejection region? Sorry, so that this is acceptance region. Okay, this is acceptance region. This is the vectors coming in acceptance region. Okay, so this is the acceptance region. Okay, acceptance. Okay, so that is, this is accept region. So what will be the rejection region? Yeah, other region will be rejection region. So what is other rejection region? Yeah, this is the rejection region. Okay, this will be the rejection region. I will what is it, color with a different color. Yeah, this is the rejection region. Okay, and also we have the rejection region here. Here also we consider this as a rejection region. Okay, let us color in a different way. Okay, this is in rejection region. Rejection region, and this is also rejection region. Okay, so this is in the rejection region. I will put in box. This is also in rejection region in our criteria. Okay, so what is the formula for that rejection? Yeah, this is uh, this is mod x bar minus 1 by 2 greater than c. So corresponding to the value zero point 0.3 and zero point 0.6, corresponding to the value 0.5 and 0.3, corresponding to the value 0.3 and 0.5. So we are considering that area as the rejection region. So what is this probability? Rejecting the null hypothesis when hypothesis true, that is type 1 error. So we are restricting the maximum value of type 1 error equal to 0.1. So using this we can obtain the value of C. So that is the technique. So let us find out these values. Okay. Okay. How can we find out this probability? It's very simple. You know, let us write this example. Okay. So this is a formula. How can we solve this formula? Let us take the complementary region. So what will be the, so let us take the complementary region. So what will be the complementary probability? 1 minus 0.1 equal to 1 minus this one. So what will be that? 0.9. This is exactly, instead of 1 minus we can put here less than or equal to. Okay, less than or, so we can remove this part. Okay, we have so we can explore this mode formula. What is mod x less than c? That is minus c less than, can put the bar sign also here. I corrected that. Yeah, this is the we have used the mode the definition of mode, and now we explore with by substituting x bar. Hmm? What is x bar? X bar is exactly equal to, yeah, that is summation I equal to 1 n xi divided by, what is that, 5. We have only 5 number of random variables. What will be the next step? This 5 can be moved to here, and here also. So what happens? It will become 5 by 2. It will become 1. Okay. So what will be the next step? It is exactly given in this book. What will be the next step? What will be the next step? Let us put k for k exactly. K is equal to 5c. Okay. So this is the what is the final expression of the, what is that? We are after restricting the probability of type 1 are equal to 0.1. Okay. So uh, now look at this table. So what are the possible values of summation I from 1 to xi? You know, from this table we can have possible values are 1, 2, 3, 4, and 5. Okay, this is that final values, sum values. So that the possible values of sum is 0, 1, 2, 3, etc. 5. So then what will be the possible values of summation I from 1 to xi minus 5 by 2? So what will be the possible values? Summation I from 1 to 5 xi minus 5 by 2, that is equal to 0 minus 2.5, that is minus 2.5, minus 1.5, minus 1.5, etc. Or we can find out from here. So this is equal to 5 minus 2.5. So what are the values? 2.52, 2.5 to minus 2.5. So that is displayed here. Okay. So what is the probability? Number of favorable case by total number of cases. Hmm? Number of favorable cases by total number of cases. You know that if xi follows Bernoulli distribution, what is the distribution of summation xi? It is binomial 5 comma 1 1 2. Okay, if xi follows Bernoulli, because in this problem we are given that the x1 x2 xn x5 are sampled from Bernoulli 1 comma p. So the distribution of summation will be binomial. Okay, so using this binomial distribution we can find out what is that. Yeah, we can find out the probability of summation I from 1 to n xi. So what is the formula for finding probability for summation xi? That probability of xi equal to some c or some k, hmm, or some, what is it, summation xi. Okay, small xi. This is actually observed value. Hmm? Observed value. This is actually random variable equal to. Hmm? What will be the probability? You know, here we have how many observations? 32 observations are there. Okay, 32 observations. 32 possibilities are there. 32. Okay, out of these 32 possibilities, the summation will be 0. Summation will be 0 only in a single case. So what will be the probability? 1 by 32. So what is the value of 1 by 32? So let us take, let us denote the probability here. Mm, probability. Probability. Okay. So how can we find out the probability? The probability formula will be NC. What is the probability formula? I think this is L. How the 0 1 by 2 raised to 1 by 2 raised to 0 into 1 minus p. 5 minus 0. Okay, so what is the value? 5c0 is only 1 into then 1 by 2 raised to 0 is 1 into then 1 minus 1 by 2, that is 1 by 2. 1 by 2 raised to 5 is 1 by 32. 32. So the value is 1 by 32. This is the value. Okay. When summation x equal to 0, this is the value. When summation x equal to 1, what happens? When summation x equal to 1, so again we have 5 into 5c1 means 5 into 1 by 2 raised to 1 means 1 by 2. Then 1 minus 1 by 2, 1 by 2 raised to 4 means 2 raised to 4 means 16. So so that is again 5 into 0.0315. So what is the value of that value? 0.15625. 0.15625. So that is the value for uh, value for summation x equal to 1. So sorry, here we have to use 1. Okay. So what will be the case of when summation x equal to 2? Hmm? We should. What is the value of 5c2? 5 factorial by 2 factorial into 3 factorial. So that is exactly 5 4 into 5 10. Okay. 10 into 1 by 2 raised to 2, that means 1 by 4. Hmm? Then 1 by 2 raised to 3, that means 1 by 8. So what will be the value? This is again 32. So 10 into that is 0.3125. Okay, this value is 0.03125. So another case we have, another case is when summation x equal to 3. What will be the value? This will be 5c3 is exactly 10 again. Not 10. Same as 5c3, so it is 10 again. So that will be, I think that is given in, yeah, 312, 312. 10 again, uh, this will become 8 and this will become 4, same value. Okay, okay. So what will be the uh, probability for xi is equal to 4? This will be 5, 1 by 16 into 1 by 2, that is 5 into, okay, so that will be 15625. Okay, last case is this one. That is just 0.35 only. So that is okay. So we obtain all these probability values here. We have computed that values. Remember that this is considered when under null hypothesis. So we have to put one. Okay. These are computed when we use the condition that null hypothesis is true. So we obtain these observations, the values. Okay. So let us consider we can accept only when we get the sum is either 2 or 3. We can accept the null hypothesis when sum is either 2 or 3. Okay. That means we have to reject when we observe either 0 or 5, when we observe the sum 0 or 5. So it is clear that we have to reject h0 when k is equal to what is that? K, the value of k is equal to plus or minus 2.5. Okay. Yeah, this is equation number 6. Probability of minus k less than or equal to summation I from 1 to xi minus 1 by 2 less than or equal to k. That should be equal to 0.9. Okay, that should be equal to 0.9. So look at this figure. If you add these four observations, we know that, or if we add these two observations, we can see that it is just only 0.07, approximately 0. What is the value? Just look at this value. Yeah, that value is that here it is given here. That is only 0.625 only. So that is less than 0.1. Okay, that is less than 0.1, or the region which is satisfy equation number 6. In this region we have more than 0.9. Okay, so what would be the value of summation xi and summation xi for the rejection? It will be either 0, summation xi should be 0 or 5. In that case we have only the probability is this one, and this is less than 0.1. Okay, so we should reject summation xi when summation xi equal to 0 or summation xi equal to 5. That means we have to reject when this summation xi minus 5.2 is minus 2.5 or plus 2.5. So the possible values of k would be plus or minus 2.5. So if we select k is equal to plus or minus 2.5, we have to reject the null hypothesis. Okay. So another possibility is, since it is not exact, the sum is not exactly 0.01, it is not exactly 0.1. Okay, so we have to consider the next remaining values. What are the next remaining values? 1 and 4. Okay, corresponding to 1 and 4 we have k values minus 1.5 and plus 1.5. Okay, corresponding to 1 and 5, sum 1 and 4, sum equal to 1 or 4, we have k values, the possible k values is equal to minus 1.5 and plus 1.5. So when we add this add the probabilities corresponding to sum equal to 0, 1, 4 and 5, we get the value like this: 0.0625 plus 2 times 1.625 and 1.625. So that is 0.375. So but this is much larger than 0.1. Okay, this is much larger than 0.1. So we cannot reject the null hypothesis when we observe these four observations. But we can reject if we observe 0 or 5, but we cannot reject when we observe 1 and 4 including 0 and 5, along with 0 and 5. So we cannot consider this as the criteria for rejection, because the rejection probability exceeds 0.1. So what will be the alternative procedure? We can fix summation xi equal to 0 and 0 or 5 for the rejection of the null hypothesis. At the same time, when we observe, we cannot reject directly, but at the same time we can uh, uh, we we can consider some randomized procedures. Okay, so what a randomized procedure is to find is to compute the probability of rejection, uh, compute the probability of rejection, that is gamma, for when we observe summation x equal to 1 or 4. Okay, we can reject the null hypothesis when we observe summation xi equal to 1 or 4 with the probability gamma. You know that we can reject the null hypothesis when we observe summation xi equal to 1 or 4 with the probability gamma. So we cannot surely reject when we observe summation xi equal to 1 or 4, but at the same time partially reject. What is the partial rejection probability? Yeah, that is gamma. Okay, if we observe summation x equal to 1 or 4, we can reject partially the null hypothesis, and the probability of rejection is, if you observe summation x equal to 1 or 4, the probability of rejection is gamma. Okay, how can we find out the gamma value? Yeah, we can use this equation, that is probability of rejection is equal to 0.110, that is exactly equal to the probability of rejection when we observe summation x equal to 0 or 5 plus gamma into probability of rejection when we observe summation x equal to 1 or 4. Gamma is the proportion of rejection of this null hypothesis when we observe summation x equal to 1 or 4. Okay, in this case we can certainly reject. At the same time, if you observe like this, we have to reject with a probability gamma. This is certain, this is not certain, this is random. How much random? Gamma times, or gamma, there is a probability of rejection when we observe summation x equal to 1 and 4, that is nothing but gamma. Okay, so the entire rejection probability can be computed like this. Okay, using this formula, you know, this we have already computed, but the first probability 0.0315 plus 0.0315, and gamma is not known, and the what is the probability of summation x equal to 1 or 4? Yeah, that is 0.15625 plus 0.15625. We can substitute that values here, and we can obtain the probability as, what is that, gamma, as gamma is equal to, what is the gamma value of gamma? Yeah, let us compute this, that formula. So let us compute that formula, that is 0.1 equal to probability of summation x equal to 0, summation x equal to 5, that is 0. What is that value? 1 or 5, that means 0.033125 and 0.01033125. Okay, plus gamma, let us put y instead of gamma, into, then what is the probability of summation x equal to 1 or 4? That is 0.15625, that is repeated 2 times, 0.15625. Okay, so using this formula we can find out the value of gamma. Gamma equal to, what will be gamma? What is the value of gamma? 0.1 minus 2 5, okay, divided by, this is 2 times. Okay, so the what will be the value of this expression? Yeah, that is 1 minus, that is equal to 1 minus, not 1, 0.1 minus 0.625. 25, okay, divided by, what is 2 times 0.15, that means uh, 3125. Okay, by, okay, one divided by this one, 1 2. But in this book it is given that 0.114. At the same time, in the Excel we can see that it is 0.12. So okay, so it is round, it is a rounded figure, no problem. Anyway, this is the value 0.124. Okay, so we obtained that gamma is equal to 0.114. So a randomized test for alpha is equal to 0.1510 is therefore the test function will be phi of x equal to 1 uh, if summation I from 1 to n x equal to 0 or 5, and summation x equal to 0.114 if summation I from 1 to x equal to 1 or 4 and 0 otherwise. So this is a procedure for finding the test function for a randomized test. Okay. Uh, so in this problem we can reject with probability, we can reject with the probability 1 when we observe summation x equal to 0 or 5. We can reject with the probability 0.114 if summation x equal to 1 or 4. Okay, so this can be considered as a test function. Test function, that means test function is equal to 1 means we can reject with the probability 1 if summation x equal to 0 or 5, and can reject with some 0.114 if summation x equal to 1 or 4 and 0 otherwise. So this is exactly expectation of phi of x. Expectation of phi of x. We can see that. Let us create the formula. Under null hypothesis, that equal to, using this expression phi of x, what we can obtain, 1 into probability of okay plus plus 1 or 4 plus 0 into probability of okay. So, so look at this, look at this expression, okay, and look at this expression. What is the similarity? Okay, you can see some similarity in these two expression. So this is the expectation of phi of x under null hypothesis. That should be, that is kept as 0.1, and instead of gamma we have 0.114. We have obtained value of gamma as 0.114, and the expression for probability of summation x equal to 1 or 4 is given here, and no other term, that is 0 into probability of otherwise. Here also there is no term with so that is multiplied with 0. Okay, so using this expression we can consider phi of x as this one, because if we consider this as a phi of x, the expectation will be this one. So that is similar to the expression we obtained using this construction. Okay, so this is a randomized test. This is a randomized test function for the rejection or acceptance of null hypothesis, and using this test function. So we have identified the test function. We have identified this test function by using this expression, because that expression is nothing but this one. So expectation phi of x is this one. So what will be the phi of x? So phi of x should be like this. So that is the idea. So we have identified the test function. Okay. Now after identification of the test function, we can find out the power of the test. So what is the criteria of a testing hypothesis? We have to fix the probability of type 1 error, and we have to maximize the power. So in order to maximize the power, we have to find out the power of the test. What is power of test? Expectation of p under phi of x. That is, what is that? Yeah, this one. Expectation of p phi of x, that is probability of p. Because in the alternative case, we are not given that p is equal to 1 by 4 or p equal to some other 3 by 4, etc. It is given only that p not equal to 1 by 2. So just to use the notation p itself. So ep of phi of x, that equal to p of summation xi equal to 0 or phi plus 0.0114 into pp of summation xi equal to 1 or 4, where p not equal to 1 by 2. So if we put 1 by 4, we can find out the power corresponding to 1 by 4. If we put p is equal to 3 by 4, we can find out the power corresponding to 3 by 4, etc. Whatever be the alternative hypothesis given or we are considering, we can find out the power based on that value. Okay. So this is a formula we can use for finding the power function. So this is an example of randomized test function. This is a randomized test function. So what is the procedure we have adopted? So we have identified the observations and we have computed the probabilities and we have tried to find out the rejection region. Since it is not clearly exactly is equal to, since the rejection probability is not exactly is equal to 0.10, so we have to find out a randomized test. In that case, we will reject the test only if 0 and 5 observe, and we will partially reject when we observe 1 or 4. Okay. So using that step, we obtained a randomized test here, that is phi of x equal to 1 if summation xi equal to 0 or 5 and phi of x equal to 0.114. How we obtain this randomized test function? By the expectation of phi of x or rejection probability using the comparing this what is that rejection probability with the with our construction. Okay, with our rejection criteria and corresponding construction. Okay, when we compare these two equations, we can easily say that phi of x equal to 1 if summation x equal to 0 or 5, or phi of x equal to 0.114 if summation x equal to 1 or 4, and 0 otherwise. Okay, so this is the power function. You can so let us look at the power function value for p is equal to 1 by 4. So what will be the power function value for p is equal to 1 by 4? How can we find out the probability? Yeah, it is not given here. How can we find out the power function value for 1 by 4? It is left as an exercise for you, and I will give you the formulas. Okay, I will give you the formulas. You may try to find out and substitute the values as an assignment. Okay. X equal to 0, 1, 2. Yeah. 0 3. Yeah, we should take this also. Okay, now we can use 1 by 4 instead of 1 by 2. We can use 1 by 4 for the computation of power. Now you have to find out the right side. I am giving as an exercise. This is for computation of power. Don't mix with the computation of probability of type 1 error. This is for computation of the power. What is exactly power? You know what is power? What is the power? Formula for power? Accepting H1 when H1 is true. Okay. Power function is rejecting H0 or accepting H1, rejecting H0 when H1 is true. So what value is true is considered here? 1 by 4. When we consider P is equal to 1 by 4, H1 is true. What is the probability of rejection? So this is the probability of rejections for various values. You have to find out the right side values. Okay, you can find out these right side values and substitute here. Substitute here. Substitute here. Power. So you have to find out these values. I will give you this word file by WhatsApp and you can use that for the computation of power. Okay. So we have discussed a randomized test problem, and uh, we have obtained a test function based on the type 1 error probability. Using type 1 error probability, we have test function, and using that test function, we have obtained the power function and power. Okay. You know to draw this figure. You write down all these things up to this the problem. You write down this problem, including the work I have given in this word format. Okay. Okay. If you have any doubt, you can ask to me, no problem. This is a lengthy discussion and you have to try to understand the